All right, where are we at here? It is December 2nd. That means that we finished December 1st, which means we have 12 more days until we are off for the semester, off for the holidays. It's looking good. Yes, quick review of our expectations. Yeah, it's the same as it was yesterday. Please don't touch anyone. Please don't hit anyone. Please don't push anyone. Please don't throw things. We've been through this, right? So please raise your hand to contribute to the class conversation. Please raise your hand if you need to go over to the front of the room here to get hand sanitizer. Please let me know if you need to go to the front of the room here to get a mask. Please let me know if you need to go to the front of the room to get tissues. All of that still applies. Because the rule number one is that you're staying in your seats. Bad things happen when you guys don't stay in your seats. So because of that, I want to make sure that everybody is sitting down until we're ready to move on. Okay. For the class itself, boom, I'll review this in just a sec.
What you do now every other day, I'll be watching you.
去吗？有致命！
Are these edits wild or what? So this is Mr. Storkerson's class, 8th grade integrated science. Once again, I can describe the pros and cons of non-renewable energy. Today we're going to be diving a little bit deeper into that with a worksheet from the notes. We spent the last 3 days going over notes. So you're coming in, doing your video intro, which you're looking at now, that has the attached bell ringer. We have a worksheet that we're going over. It looks like this. Ooh, look, a nice worksheet. It's two-sided, so make sure you do both sides. Total of 12 questions. You'll work through that. I'll make sure you have your notes from the last 3 days in order to work through that. And then we move on to an EdPuzzle. You'll notice that one of them is gone now because it's no longer Tuesday. Today is Wednesday. And so today's 20 points is going to come from doing how do wind turbines work? How do wind turbines work? It is a TED Ed YouTube video that's been converted into an EdPuzzle for you. Do that for 20 points. Once you're done, you can get going on Thursdays if you'd like to have some free time tomorrow. Otherwise, you know the drill. Do something non-disruptive in your seat. Non-disruptive in your seat if you're done with the wind turbines EdPuzzle. That is what we're getting done today. With that said, let's get going on your bell ringer.
This is a rattle from a rattlesnake. I've always wondered how rattlesnake rattles make sound. Well, if you look inside, you'll see it's pretty hollow. This is very surprising. I thought rattlesnake rattles worked like maracas, and they had little bits inside that knocked around to make sound. But they're hollow, so that can't be the case. But look here, if I pull on the rattle, a piece comes off. It seems like the rattle can come apart in different sections. Here's an image that can help us see how the sections fit together. One section is highlighted in white. See how all of the segments fit loosely inside each other? Now look at this. Notice how the segments aren't firmly connected. They have space to wiggle around and move. So when the rattle is shaken, those segments knock into each other. And that's how a rattlesnake rattle rattles.
The answer to this bell ringer is a little less straightforward than yesterday's, which was just, it was a $10 billion telescope and we dropped it, and everyone could write that. Write this in your own words, 2 sentences. How does a rattlesnake's rattle rattle? That is your bell ringer question. Once again, how does a rattlesnake's rattle rattle? Here's the video once again. How does a rattlesnake's rattle rattle? There's your bell ringer question, 10 points. And then let's get going on the renewable energy worksheet. I'll get that to you now.